So good afternoon, or I can say good evening, everyone. Okay, so we will start our lecture without any delay. And here we start with our deep learning. Yesterday we were talking about all the deep learning. We came across the part where the deep learning, how the training process has been done. Basically, this is the internal structure, a same like we take about the how the radio works, how we adjust a radio, how a human being adjusts a radio. The same way this sample data has been working. Okay, we are using our brain and ear as an feedbacker. Okay, to make our data or to make that notch stand at the proper place. So we are keep on doing forward it to the network to get prediction, back propagate the error and update the connection bits. Okay, and we were talking about conven- now to convolution neural network. Okay, we are going to learn about those. I did skip some of the two topics, but they were not included for this syllabus for purpose now. Okay, now this year the convolution part is very much important because you are going to use it at the far more basic in nature. Okay, so we start convolution neural networks learn a complex representation of a visual data using a vast amounts of data. They are inspired by the human visual system and they learn multiple layers of transformation which are applied on a top of each other to extract a progressively more sophisticated representation of the input. Okay, understand this thing? Excuse me. Let's read the definition again and understand them as sooner. This is a convolution neural network definition where you will get a whole equation within those defined definition only. Okay, convolutional neural networks learns a complex representation of a visual data using a vast amount of data. Convolution neural networks learn a complex representation of a visual data using a vast amount of data. They are inspired by a human visual system. They are inspired by human visual system and they learn multiple layers of transformation, multiple layers of transformation which are applied on the top of each other to extract progressively more sophisticated representation to the input. I have read this again and now with a very slow pace, making you understandable more and more. So understand this that this convolution is a complex representation of any visual data with the help of vast amount of data. Whatever we are giving is being converted into the complex representation which is known as convolutional neural networks. Now, this neural network has been inspired by our human nature, how these humans can see a image and how they take that vast image, or you can say a big image, into the forefront and use it as an classifier or something. So, that type of technique we are using which in a convolutional neural networks. That's the reason it is so much very important significance as well as amazing to learn because it is has a system how the human eye actually works and they learn a multiple layer. Excuse me, I just having some sneeze problem. Multiple layers of transformation which are applied on the top of each other extra. On the top means that one by one we will create a whole different layers. I said just like for a classification of different formats and we will come together and make it a whole one sophisticated representation for the input. Okay, So as you have seen, let's every layer of CNN takes a 3D volume of a number and output of and a 3D volume of numbers. Example image of 22 into 22 RGB cube and will be transformed to 1 into 1000 vector of probabilities. Can you imagine this how this has been transformed, depth, height, and again it is been showed into the very smaller part. Why this has been doing, like they are taking a vast amount, I told you about the vast amount of image into complex representation. This becomes, they are converting the whole image, a clear image into a smaller complex version in the 3D volume, into the 3D volume. Now this 3D one, how this 3D volume is mapping to you, I'm saying this 3D volume is represented. It's a representation. Something is not created into 3D. It's a representation. We are trying to take a data into the one form of 3D so that it will give you a proper output and the whole data is been sophisticated. Example, just like a paper. If you want to, whenever you take give a letter, what is a better way to take a letter or give a letter? It's after writing a paper and folding it to a some extent, till what, till some extent, as they are data. So what we are here so it's on a form of almost a paper, almost a image, right? Almost a paper it's look like. So what we did, we just folded it and kept in a proper manner. But this time the data is won't be folded like a paper. It's being converted from one form to 3D volume other form. Okay, the form that we are considering is also a 3D, and converting into the next form which is also a 3D. Okay, that makes its area same. The whole data was able to come within those. So this is a process. Can you see blue color and this depth and again this is a process that how it's done one by one, instead of going the from taking a whole page and converting into direct to 10 folds. No, because 7 folds are max. Okay, 7 folds are max, and people can go after that also. But this is a data form, so you can convert it into the any other shape as well. If you want a circle, you can convert a circle. Just they need a proper convolution method to do those. So but here we have converted in from to 1 into 1, height height and width into 1, and depth is approx 1000, which is probabilities we call it. Okay, now can you see how this been done? Just check it, understand this part, how is been showed, how is been done. Can you see? They have showed all the stages of completing or taking that image as into the one form, that image into converting into the thousand to one form. Okay, now convolution layer is a feature that detector that automatically learns to filter out not needed information for an input by using a convolution kernel pooling layers, compute the max or average area value of a particular feature over a region of the input data. Downsizing the input image also helps to detect objects in some unusual places and reduce the memory size. So now this whole convolution network is not decided within a just two definition. It's just a method that we are trying to talk about. Convolution layer is a feature detector that automatically learns to filter out not needed information, required not needed filtration from an input by using a convolution kernel. what they do, the filters and the data which not needed can be filtered out it. As you know, we are when we are converting a whole data into a single slab or a probability of 1 into 1 into 1000, there are some of the non inputs that we may not require. Now this not requirement is been done by convolution kernel, but how there are more and more factors within this convolution neural networks that also drives all those things within that type of algorithm. Polling layers compute the max or average value of a particular feature over a region of the input data. Polling layers compute the max or average value of a particular feature over a region of input data. Do you know about having sharing the images on WhatsApp? How this image sharing images on WhatsApp work? Okay, when you share a 5 to 6 MB images on WhatsApp, and the receiver who is receiving always get the very less in KBs, from MBs to KBs, but still the images look same. The images exactly look same. The compromise is the detailing. What we compromise? We compromise the detailing over there. As you can see the same, if you zoom both the images, you will find that certainty between them. Most of you have done this and uh, already have seen that type of thing. Okay, how all these things works. But if I tell you in a more deeper understandable manner how it's supposed to be happen, how it's supposed to happen, so you will understand it more quicker and better. Okay, so can you see the edge blob, the texture objects and objects close? Can you see this 254, 254, 54, 3? Okay, now converted into the 55, 55, 96. Now let's have a bit calculation. I will just have a calculation of 224. Okay, 224 into 224 into 3. How much it is? 1 almost 1 lakh 50,000. Okay, so what if I just try to do it 555 into 55 into 96? uh, Now it's a bigger one, but what is happening? So let's do make it more clear. 27 into 27 into 256. Now it is getting a smaller. What we are doing over here, first we take a data into the sum form and we max pulled it. We are max pulling it again and again. What is a max pulling? Compute the polling layers to compute the max or average values of a particular feature over a region of the input data. What it will doing? It will take a always a value. Can you see the size of images from the side are getting lower, side and lower and lower? So that's how it's been working. That's how it's been working. It's lower and lower and lower every time. But can you see the data what has been showed within that? It's been also been lowering, like it was, if you are taking a slab within for 11 11 of that, 11 of 11 size of that, and the same data is been shared in 5 5 5, again in 3 3 3 3 3 3 3 3, and again into a tiny part, then we make it dense and more dense. So what is happening over here, the whole slab is converting into the one form of a small slab, where the some of the output data which are not required is been deleted. Okay, which are not required is been deleted, and as soon as we go into further, we will see how that data makes it in a dense area. Okay, now I could have shown you a proper example more, but this is something level you need to understand. We will try to make it more. It won't be easy to, because if it's that easy, then it will be able to learn by anyone. But I'm saying it's a bit a twisted. It just require a bit practice or more a bit more some bit more explanation, and you will get how it works. So we come here on the next part, which is recurrent neural nets. Recurrent neural network. One but to one to many to one, many to many, many to many. Understood? No? Okay, let's read the definition. RNN, recurrent neural networks, are general computer which can learn algorithm to map input sequence to output sequence. To map input sequence to output sequence. Flexible vectors or flexible size vector. The output vectors contents are influenced by entire history of inputs. The output vector's contents are influenced by entire history of inputs. State of art result in the time series prediction, adaptive robotics, handwriting recognition, image classification, speech recognition, stock market prediction, and the other sequence learning problems. Everything can be processed sequentially. So now what this RNN is trying to say that the general computers we learn algorithm into input sequence to output sequence and flexible size vector. The output vector contains the influence by the history of inputs. The same understand this method the RNN try to give you the same output but a better input means where the beginning is the end as well. Like we are taking the data and making it more and more sophisticated by doing all things and making our output more and more inputable. We are using the output as an input as well. That's the reason it's making it more. So let's try this, understand this RNN part. Okay, a short term memory LSMT network is a particular type of recurrent network that works slightly better in practice, owing to its more powerful update equation and some appealing backpropagation dynamics. The LSTM units give the network memory cells with a read, write, and reset operation. During training, the network can be learned when it should be remember data and when it show to throw it away. Well suited to learn from experience to classify, process, and predict time series when there are very long time to lags a unknown size between a between a important events. I would like to skip this part for now because it's gonna be a more and more deeper. So I will just skip for now and I make in a general texting form. I will show you how this that works. Okay, to learn RNN, insert a character sequentially and predict the probability of a new letter. Backpropagated error and the update the RNN's weight to increase the confidence of the correct letter green, and decrease the confidence to all letters red. Means what we are going to do? We are going to predict our main form, but with the help of this backpropagate error, which is also in the simpler form, I also known as a feedback form. But how this is happening we will see. So the input layers are 1110 111. The green ones are hidden layer and the outputs are E. Output layer are targeted character E 2.2% I minus 1 3 and the emperor traveled back in torture. This is the whole train structure on a Wikipedia Markdown networks. Learns to spell English word completely from scratch and copy the general synthetic structure. Basically, what we are learning from our input as well. Means we are trying to take all the matter within those and keep on trying it again and again and again into the following manner. Okay, now general texting. Now here we came on the natural language processing word to word specs. Okay, this is something that's a bit beyond our RNN. So I'm going to take a bit questions on RNN. If you have any doubts, you can just comment on a section. Comment section is open. Anyone have any type of doubts? Anyone have any type of doubts?